through on these learning targets. So from lesson 1.4, we're going to learning target 3, finding the rate of change. And I'm not as particularly concerned. Give me 1 second. I want to do this real quick. I know some of you are still flipping through notes. The rate of change is the ratio between the change of one variable and the change of another. The ratio of change is the change between one variable and the change of another. The ratio, and for us, it's going to be the ratio of the change of the heights. What coordinate is associated with height? Y. And the change of the horizontal distances, or horizontal points. So that's our x. This is in the packet. It is on, it's under observation of points on a line.
Rate of change what?
Rate of change is the ratio of change of the heights over the change of the horizontal points. Now, you guys already know what this is. You call it something when we have linear equations. The slope, aka, at least for linear equations, the slope. And so we're going to define the slope, and then we're going to look at these examples and see what we can conclude from them, because these are related to the graphs we did before. So at the bottom, this is on the third page, I think, right? Bottom of the third page, second actual paper page. What is slope defined as? You learned it in middle school. Who knows? Yes. Rise over run. Rise over run. And rise is the change in height, okay? And run is the horizontal change. And we're looking at that between 2 points, yes?
My old math teacher told me a trick for rise over one is to purposely spell rise wrong.
With a Y?
Yeah, spell with a Y.
Rise is the Y. Yep, you could do it that way. Yep, and then run is the X. So we're going to look at our examples from yesterday, looking back at our graphs from the very first learning target. And unfortunately, I don't see where my paper is for this. Maybe it's over here. Nope, we're just going to have to go with this. All right. So you don't need to pull this out. I'm going to put up the graph from yesterday, which is this one, same equation. And here's our graph for it. If you look between 2 points, to go from left to right, I'd have to go down 4, 1, 2, 3, 4, and right 3. So what is our rate of change or our slope? Negative 4 over 3. I'd have to go down 4 and over 3. So it's negative 4 over 3. Now, you could say negative 8 over 6, because between this point and this point, it's down 8 and over 6. Well, that down 8 over 6 reduces to negative 4/3. So we're looking at this as a ratio. We're supposed to reduce the ratio as well. David?
So if the 3y is the rise, then why is the 4 on top?
Great question. Now, I wasn't going to teach it this way, but all of you have seen slope-intercept form before, right? Yes. So let me show you what happens if I solve this for slope-intercept form, and then we're going to see what conclusions we can make about it. By the way, what form is this equation in right now? Raise your hand if you know what form this equation is in right now. Peyton?
It is in
standard form. The equation's in standard form. So if I start out with 4x plus 3 equals 12, and I'm trying to get y by itself, I'm going to subtract 4x from both sides. This gives me 3y equals negative, you don't have to write this down, negative 4x plus 12. Divide every term by 3 to undo the multiplication of 3. And we have y equals negative 4/3 x plus 4. So there is in slope-intercept form, and since you already know a little bit about that form, we're going to look at standard form compared to this. In this form, you can see the slope, and we just saw it from the graph. If I have it in this form, I have two options. I will tell you my preference my whole life has been just solve for y and look at what the slope is that way. Then I don't have to worry about making any algebra errors or sign errors when I'm subtracting or dividing. But I have a lot of people who don't prefer to do it that way, and they don't make a mistake doing it. Where did the 4 come from, the number 4? It's the coefficient on x, right? And the 3 is the coefficient on y. Well, it turns out that when we have an equation in standard form, and I'm going to write this up here next to rate of change, if we start with an equation in standard form, which is ax plus by equals c, we can get the slope. Well, let's see if we can figure out how. Remember, you guys said, wait a second, Mr. Ritter, that says 4x plus 3y equals 12, and you ended up with negative 4 over positive 3. So where did this negative 4 come from? Yeah, when I subtract it. So it's the opposite of the coefficient on x. In this case, our slope, or our rate of change, is the opposite of the coefficient on x over the coefficient on y, as long as it's in standard form. If they're not on the same side of the equation, it's not in standard form, so you're probably better off just solving for y then. But if it is in standard form, you can do the opposite of the coefficient on x over the coefficient on y, and it will give you the slope. So also, notice here it says that we are finding the rate of change for linear equations from example 1. Are all of these linear equations? No. We're going to come back to this one, and even letter F to make a note about those, but the ones that we would be expected to do for rate of change, although you'll see it pretty clearly on those, are A, B, D, and E. So when I do this, I'm going to take a look at this problem. Let's take a look at letter A. What should my rate of change or slope be for this one? Raise your hand if you think you know what it is. I have 7 people, 8 more hands are going up. Aaron, what do you think?
2 over 5.
It is going to be positive 2 over 5. I start out as saying, though, it's the opposite of 2 over the coefficient on y is negative 5, and so that does simplify to positive 2/5. Those slopes are equivalent, but we always write it as a positive. It's negative divided by negative.
Why do you make it the opposite?
I just change the sign. If it's positive, I make it negative. If it's negative, I make it positive.
Okay.
Yep. All right, I'm going to ask you to do this for letter E. Try this for letter E, as in you're going to do an excellent job. Letter E. 10x plus 15y equals 30. You should reduce it, yes. So, did everybody get negative 2 over 3 when they reduced?
Yes.
Would anyone like to see it worked out? Okay, and I know people in the video are probably going to want to watch it too. So, if I do this as the opposite of 10 over 15, because this was positive 10, I do the opposite sign, and then 15 was the coefficient on y. They are both divisible by 5. So dividing the negative 10 by 5 gives me negative 2. Dividing the 15 by 5 gives me 3. So there's my rate of change. Natalie, does that make sense? Kind of. So just make sure you grab the opposite sign of the coefficient on x and then the coefficient on y and make a ratio. Now, if you don't like that way, do it the way Mr. Ritter's done it his entire life, which is solve for y, like we did on that first one, and then you'll see the slope, and there's no question about it unless you made an error in solving. All right, now I do want to talk about the absolute value ones, and I wish, oh, I do still have a graph. Good, good. All right, so I'm going to look at this example. I'm just going to pull up. You don't have to turn your papers. We're just going to take a look at this and see what we can see. First, I think we should look at B, and then we'll look at this one. So we're going to look at B. Notice the equation here. If we didn't have an absolute value, what equation would that be? Y equals negative 2x. This is negative 2 over 1. It's being multiplied by whatever comes out as x. Well, I start at 0, 0, my vertex, and if I look carefully, this is going down 2 and right 1, down 2 and right 1, down 2 and right 1 when I go to the right of my vertex. When I go to the left of my vertex, going from left to right, I'd have to go up 2 and right 1, up 2 and right 1. So what slope do I have on this side? Negative 2 over 1. What slope do I have on this side? Careful. It's going up 2 and right 1. 2 over 1. Positive 2 over positive 1. Because you're going up and right, and both of those are positive directions. Thank you. Yes, right there. Thank you. Thank you. All right, so notice that they're the opposite slopes. The absolute value, the one going from right to left from the vertex, is the one I see in the equation. And the other one is its opposite sign. Okay, not just reciprocal value. Or not even reciprocal value. Let's take a look at this one. By the way, what number is multiplied by the x plus 1 that we don't see? Andrea, what do you think? 1. So we have 1 over 1 in front of there. If you look at the graph that we did in example 1, this goes up 1 over 1, up 1, right 1, up 1, right 1, up 1, right 1. Remember that right and up are positive directions. The other one goes, if I'm going from left to right, down 1, right 1, down 1, right 1. So this is a slope of negative 1 over 1. This is a slope of positive 1 over 1. So remember, left is negative and down is negative. So same thing, from the vertex, it splits it into 2 different slopes for absolute value function. And those pieces are linear. All right, now let's get to the part that I really want to get to, because we're talking about rate of change, and with respect to our linear equations, that's called slope. So we have what's called the slope formula. I'm going to pick a different line, and I don't have one graphed. We'll just do this. Okay, you see this one right here, right? We all get that this was up 4 and right 2. So that's positive 4 over 2, which is what? 2 over 1. Okay? Now, that had a vertical change of 4 units between this point and this point. This point was at 8. This point was at 4. How could I calculate the height using the 8 and the 4? Subtract them. Yep. And then on the x's, this x was at 0, and this x is at 2. So how could I have calculated this distance of 2 using those 2 numbers? Subtract them. 2 minus 0. 8 minus 4, 2 minus 0. What I'm basically doing is taking the y coordinates of the point and subtracting them to get that vertical distance, taking the x coordinates of these points and subtracting them to get the horizontal distance. The vertical distance is the rise, the horizontal distance is the run. So what I'm doing is, if I have 2 points, x sub 1, comma, y sub 1 being my first point. That's why it has the sub 1. It's the first point. Usually when we're reading left to right, it's the one on the left. Although if you switched them, it wouldn't be a big deal as long as you completely switch the points. Point 2 being x sub 2, comma, y sub 2. That's what the subscript 2 stands for, is that it's the x and y coordinate of my second point. To calculate the rise, which is what we have written over here on the left side, to calculate my rise, I'm going to do y sub 2 minus y sub 1. And that's going to give me the vertical distance, the height. The vertical distance between the 2 points. To calculate the run, I'm going to do x sub 2 minus x sub 1. This is the slope formula. We use it a lot in geometry. This is the horizontal height distance. Not height, horizontal distance. So that's our formula to find the slope. Because you're not always going to be given a graph, and sometimes your points are so far apart you don't want to graph them. It's kind of a pain in the butt. So you can then just use the slope formula to find the slope. I'm going to rewrite this formula, so if you haven't written it down yet, I'm going to put it on the top of the next page also. Feel free to take a peek at it if you want to just grab a bunch of them. All right, it's back on. So we have y sub 2 minus y sub 1 over x sub 2 minus x sub 1 as our slope. I'll get to the graph in a second. Now, a lot of people, when they're first using this formula, are like, wait, where do all the numbers come from that you plugged in? I picked this as my first point, so I labeled this coordinate x sub 1, that's the 4, and the 10 would be my x sub 2. Those are my x coordinates. Sometimes people even circle them. Now, as we go throughout the year, you'll be so fast and efficient at calculating slope, you're not going to need to label them. But to start, I usually have students label them. This is my first y coordinates. Goes with x sub 1. I have y sub 1. So above it, I'm going to label it y sub 1. And I'm going to circle the sign with it. I have to include that negative with it. And then my y sub 2 is positive 5. Well, now I'm just plugging them into the formula. Y sub 2 minus y sub 1. So 5 minus a negative 3. What happens when I'm minusing a negative? It becomes positive. So I'm doing really 5 plus 3, which is 8. My x is, and I did it in the wrong color, oh well, is x sub 2 minus x sub 1 is 10 minus 4, which is 6. And 8 over 6 will reduce to 4/3. So the slope, without graphing it, I can get the slope of 4/3 just by subtracting my y's on top, subtracting my x's on bottom, and reducing it. What would have happened if I had accidentally did 4 minus 10 on bottom? Would I have gotten 6? I would have gotten negative 6, right? Would it be the same slope? No. So the order is important. If I start with this as my second point when I do my y sub 2, then this has to be my first x that I plug in when I subtract. Let's look at the one next to this. Here's my x sub 1. Here's my x sub 2, the 4 and the negative 4. And my y sub 1 is 0, and my y sub 2 is 0. So the x sub 1, y sub 1 together, the x sub 2, y sub 2 together. The formula is to subtract the y's on top to get the rise, and subtract the x to get the horizontal distance. So I have 0 minus 0, which is 0. Then I have negative 4 minus 4, which is negative 8. And the question is, what is this slope? 0. 0 divided by negative 8 is 0. What that means, right? Think about this. Our run is negative 8, which means on the graph, my line goes left 8. My line goes left 8, but it doesn't go up or down. So what type of line do I have? A horizontal line. We'll talk more about that later. All right, so that's a horizontal line. I'm going to show you the example with this, with the graph. The trick with the graph is you have to make sure that whatever points you pick, it's exactly on the corner of the square, of the squares. It's exactly on what I call the crosshairs. It does look like this point right here actually intersects the x-axis right at that point. So that's going to be one of our points. It's a little hard to tell on this graph. And this one intersects right on the y-intercept, which is helpful. But we're just trying to find 2 points where they intersect. Now, we're going to call this guy Billy, but you can call it anything you want, or this girl, whatever. They're going to walk from left to right. As they walk from left to right, are they going to go uphill or downhill? Uphill. So do I expect a positive slope or a negative? Positive. We are expecting a positive slope. Now, going from left to right, to get from this point to this point, I would have to go up. 1, 2, 3. I'd have to go up 3 and right 1, 2, 3, 4. Right 4. Remembering that both up and right are positive directions, so positive numbers, our slope is and we'll use an M for it, is 3/4. Now I've had other people who said, well, Mr. Ritter, I didn't do it from left to right, I did right to left. So instead they went down 4 and left, down 3 and left 4. Well, down and left are negative, right? So shouldn't they still have gotten 3/4? Yeah, because -3/4 is equivalent to 3/4. So technically my answer is 3/4. But by the way, this comes in handy when we go to graph. If I have this point, I can either go up 3 and right 4 to get the next one, or I can go down 3 and left 4, down 3 and left 4 to get the point behind it. All right, try this for letters B and D. You're going to try letters B and D. If you can reduce it, great. If you can, at least plug it into the formula and see what number you get on top and bottom. Correctly, you should have gotten -3/2 as your final answer. Or maybe you have 3/2. That's equivalent. Okay? In doing the rise over run, I do y sub 2 minus y sub 1, 14 minus -4. That becomes a plus because of the double negative, which gives us 18. The run, -2 minus 10, gives us -12. Both are divisible by 6. By dividing those both by 6, you get 3/2. And it's overall, the fraction is negative because only one part of it is negative. So it doesn't matter whether you have this as -3/2 or 3/2 or -3/2. It's all the same. The opposite of 3/2 is the same. Any questions on letter B? Yes? Where did I get? No, that's -10. Sorry, my handwriting's terrible. All right, let's take a look at letter D. Everybody should have gotten 4/0. If you made this your y sub 2, y sub 2 minus y sub 1 would give us 4 minus 0 over, this is our second point, so that's our x sub 2 and that's our x sub 1. -5 minus -5, take the sign with it. What happens when you've got minus a negative? It becomes positive. It's like negative times negative. So it becomes positive, which adds to 0. Now I had a lot of people today tell me that the slope of this is 0. And then I had to solve that. I had to ask them, well, wait a second. What is 6 divided by 3? Why is 6 divided by 3 2?
Because 3 goes into 6 twice.
Well, 3 goes into 6 twice, but it's the inverse of a different operation. What's that other operation? Somebody said it. 2 what? 2 times 3 equals 6. 2 times 3 equals 6. So the reason that 3 goes into 6 evenly is because 2 times 3 is 6. 2 groupings of 3 gives us 6. So when I had the number earlier of 0/8 and we said the slope was 0, well, that should make sense because 0 times -8 is 0. 0 times -8 is 0. What number times 0 is 4? Nothing. Anything times 0 is 0. So there is no number. So this is what we call undefined. Whenever you have 0 in the denominator, that fraction is not a number. It's undefined. So what we'll say for this is, let's think about this in terms of the graph. I have a rise of 4 units, but it doesn't go left or right. So what type of line do I have? A vertical line. All right. Now that we know slope, you guys already knew how to find it on the graph, but now you know how to calculate it. We're going to look at graphing using a table, or no, we're not using a table. We already know slope-intercept. So jump down to slope-intercept form. We're not going to explore if you've already seen it before. We have y equals mx plus b, where m is our slope And B is our y-intercept. All right, so we're going to flip the page. And our first problem, which one is the slope? What is the slope? The slope is positive 3 over positive 5, which means I'm going to go up 3 and right 5. What else could I do instead of up 3 and right 5? I can make this down 3 and left 5 because negative over negative is still positive. So I could go down 3 and left 5 if I want to. Now, my y-intercept as an ordered pair would be 0 when I plug it in, 0, negative 2. But if you want to write b equals negative 2, and we know that you mean that that's the point on the y-axis. Okay, but as an ordered pair, it is 0, negative 2. So I go to negative 2 on the y-axis, which is the point 0, negative 2. And from there, I have my choice, and I'm actually going to do both. I'm going to go up 3 and right 5. And unfortunately, I can't go up 3 and right 5 again. And I have to fill in all the points that I can on this graph. So I'm going to go down 3 and left 5. And then I can connect them. Make sure I put arrows to indicate that it is a line extending past the graph we have drawn. Yes, Tyler.
What does it say under the B?
It says that this is on the y-axis. It is the y-intercept. The y-intercept is on the y-axis. I go to negative 2 on the y-axis. Go to negative 2 on the y-axis. For the next one, what's our slope? Negative 3 over 1. By the way, if our slope is negative 3 over 1, I could rewrite this as 3 over negative 1. Still negative. And my y-intercept is 0, comma, what? 4. So I'm going to start at 0, 4, 1, 2, 3, 4. And I'm going to go down 3 and right 1. Down 3 and right 1. And just keep going through this pattern until I come to the end of my graph that I can't do it anymore. Then I'm going to reverse that by going up 3 and left 1 to get my final point. Connect them with a straight line. Be sure to put arrows on them. All right. So I'm going to, oh shoot, Mr. Ritter, that one's not in standard form. There's two things I could do. What's one of them?
Turn it into standard.
I could put it into, I could change it to what form? Slope-intercept by solving for y. I could solve for y if I want to get y equals mx plus b. That's fine. You're allowed to do it that way. The other thing is most of us, not all of us, it's not my preferred method, but many of you could already tell me the slope, right? How do I find the slope? It's going to be opposite of 4 over 3. So if you have it that way, great. But then you're like, well, wait, I still can't see the y-intercept. How do we find the y-intercept? It's when we let x equal what?
0.
So if I cover that up, I've got 3y equals 6. Divide by 3. Y is 2. So 0, 2 is my y-intercept. So I don't have to convert the equation. Some of you might find it easier just to solve for y. You can do it either way. I'm going to start at 0, 2, my y-intercept, and I'm going to go down 1, 2, 3, 4, and right 3. That only gives me one other point. So the other slope could be 4 over negative 3. So go up 4 and back 1, 2, 3. Up 4 and back 1, 2, 3. And then I can connect my points in a straight line.
Yeah, it's positive 2.
What is it? Oh, geez. I graphed it wrong. I probably said 0, negative 2. I don't know why. 0, 2. It should have started up here. Huh. Interesting thing we're going to see. Guess what Mr. Ritter's going to do? How did I fix it, though? Made a parallel line because they have the same slope. So, but that's okay. Sorry about that. Thank you for pointing that out. All right, I'm going to ask you to try letter, that's not going to graph. Yes, it will. Letter C. See if you can at least find the slope and the y-intercept for letter C. Then we have just one more concept to talk about that'll save you having to watch one of the other videos. Some of you might have solved this, some of you might not, that's okay. Raise your hand if you know the slope. More people know the slope. Awesome. Who can I pick on that I normally don't pick on? Kevin.
-9 over -8.
Which becomes, that's the correct way to set it up. No, I'm glad you said it. It's the way we set it up, so it becomes 9/8. Raise your hand if you know the y-intercept. If you have found the y-intercept, go ahead and raise your hand. Somebody I don't normally pick on. Paul, or not, Jeff.
0, -9.
0, -9. Correct, sorry. You look like one of my other students, his name was Paul, that's why I said that, sorry. So 0, -9. So I'm going to start at -9. We have a problem, is -9 on our graph? No. So luckily it's just one tick mark away on it. Or I could just rescale it, right? I don't really want to rescale it by 2s though and go in between. So I'm just going to add one tick mark since it's only one. I'm going to go up 9 and right 8. And I can connect my 2 points and I have my graph. Yes.
So that would be on the x-axis because it goes up 9. That's one of the higher.
Oh my gosh, yes it would be, sorry. Yes, it's on the x-axis. Thank you, I went up 10. I need to count. I don't drink coffee. I love the smell of coffee. All right, if you are at home taking video notes, hold on guys. If you're at home taking video notes, you can pick up the next Learning Target 5 on the video link that can be found on my website. But for today in class, I'm going to pause this. We'll do it in class together.